Hello everyone, and welcome to this weekly session that we conduct, Ask AuxEn Anything. And as you all know, that this is an online platform for civil structural engineers to interact with us and ask their doubts or queries that they may have related to RCC or steel design or any project that they are doing or construction site related queries. So let us begin by taking the questions that have been asked on the Google form, and then we will take the queries from live audience. So I'll share my screen, and the first question for this week has been asked by engineer Sheikh Ahmed Jawad. He is from Bengaluru, and he is saying, uh, in one of the courses you mentioned that ETABS has several issues and limitations. Could you please elaborate what are those? So I was talking about ETABS 18 over there, and in ETABS 18 there were issues related to uh, some miscalculations for doubly reinforced sections. So this was one of the problems. Then there was a problem related to uh, sway calculations. Sometimes ETABS would calculate the sway, and the sway factor was calculated slightly on a higher side, and because it calculated the sway factor close to 0.04, I mean more than 0.04, it would give very high, it would take very high k values. So this was a problem that was sort of acknowledged by ETABS documentation also, and they said, they told the user to be cautious while column design, and check what sway factors, what is the stability index q that has been calculated, and accordingly what is the sway factor being considered. Another problem was some issues with auto meshing. So auto meshing in older versions of ETABS was not very well done, and it would not lead to proper load transfer sometimes. Now those issues have been made, I mean, they have been rectified in the newer versions of ETABS. And related to sway calculation, still you need to be careful. Doubly reinforced sections, nowadays I don't see problems in the calculation occurring. Okay, so these were the observations that I had. His second query is regarding structural design philosophy. Under what specific conditions or scenarios can the strong column weak beam effect and joint shear checks be safely ignored? So you follow IS 13920, go to 13920, and this code has to be applied if you are in seismic zone 3 and above. Okay, and if you are in seismic zone 3 and above, you have to check for column strong column weak beam and joint shear. Only at the roof level you are allowed to ignore the strong column weak beam. That too, I think for some story limitation is there. So otherwise you cannot, you are not supposed to ignore. Now if you choose to ignore, that is your purview, but technically if you are following the code, you are not allowed to ignore it. Okay, all right. Next question is from engineer Abraham. He is from Kerala. He is a working professional. He is asking, I hope my voice is audible. He has a query regarding the effective length factor for portal frames in column steel shed. The shed has longitudinal bracings provided along the minor axis direction to arrest the side sway and transfer the longitudinal loads. For major axis buckling, I have considered the column base as pinned and top as fixed with side sway permitted, and therefore adopted KZ as 2. However, I am uncertain about the appropriate value of KY for minor axis buckling. As per the code tables, KY1 is applicable for member with. Could you please advise whether ky equal to 1 can be adopted for the minor axis due to presence of bracing system, or whether a higher value should be considered to account for side sway effects? So you should have provided one image, because in absence of image, I am unable to make out what exactly is your structural configuration. So it would have been easier for me if an image was provided, but I don't know if there's an image. No, there is no image that you have provided. So you are saying I am certain the shed has longitudinal bracings provided along the minor axis direction to arrest the side sway. So what I am able to understand is that perhaps if I'm trying to draw a three-dimensional system, these are your portals, okay, and you have provided these kinds of longitudinal bracings, is my understanding, and this is the span of your system, okay. So you are saying that side sways permit in this direction you have taken the effective length factor to be 2, because you have a pin, a fixed base, and top, but I don't know, you're not considering the effect of rafter. So in spite of that, in spite of the presence of rafter, you have taken kz as 2. Generally we take it for cantilevers, but I'm not sure why you have taken kz2 over here. However, I am uncertain about the appropriate value of ky for minor axis buckling applicable for a member with both end spring and translational restraint. So simple answer, you may take ky as 1, you may take the length factor as 1, provided that these bracings do provide effective side sway. These bracings do provide effective restraint to side sway. You need to check that, okay? And for checking that, you could just see what is the axial load that will be transferred through in this direction, okay, what is the load that will be transferred through in this direction, and whether these bracings in tension, they are capable of taking 2.5% around of that load. So if that is the case, then you can consider it to be providing effective side sway, and then I think you can take a ky of 1, okay. So this will be my answer to your query. Next question is has been asked by, and it would have been easier if you had provided some images. Next question has been asked by uh, engineer Yash Bhope. He is from Bhusawar and he is a working professional. He is asking, I am designing a rigid connection between column I am designing a rigid connection between a column and a beam in Idea Statica. During the connection check, the weld is failing due to excessive stress. As per this clause, to satisfy the weld stress requirement, I increase the weld size from 6 mm to 14 mm and the connection passes. However, as per clause this, the maximum size of fillet weld along a square edge should be at least 1.5 mm less than the thickness of the thinner connected part. See that thing which you are talking about is in case of this scenario where you have plates like this. Okay, so imagine you had two plates like this, and here you had to fill up the weld. So in that case, this thickness of weld should be lesser than t minus 1.5 of the thinner part. So that clause that you are mentioning about is related to this sort of a condition. Now your condition over here would be that one plate is like this and the other plate is like this. So in this case, that 1.5 clause technically is not applicable. You understand the difference? This T minus 1.5 clause is applicable when you have this kind of a situation. And why this clause is required? Because otherwise, if you provide very deep weld, it will just overflow. It will overflow over here because there is nothing that is stopping this weld from overflowing. So this T minus 1.5 clause is technically for such cases of fillet welds. But your case is this, and here no such clause of T minus 1.5 is applicable. That is the first thing. The second thing is that if you want to connect two SHS, then it is better that you connect it with CJP welds. That means you will have a complete joint penetration weld. So there will be, for example, that weld will look like this, that you have a, I'm drawing the cross sectional view. This is your column and this is your beam. So in beam they will make a groove. Okay, in your box they will make a groove over here and fill it up with weld. So this is called as a complete joint penetration weld. So when you have to connect two box sections, instead of doing a fillet welding, you go for a CJP weld. The details of CJP weld you can get in the AIC codes. Okay, and when you provide CJP welds, its strength will be can taken to be equivalent to your material strength. So if you provide the weld grade up to, I think what they have given 10 ksi lesser than the parent material, you are allowed to take the CJP weld as good as the CJP weld strength as good as the material strength. Okay, so yeah, so that's what I had to say. Go for CJP welding over here. In addition, adopting rigid connections may not be very simple for two box sections like this. So making a rigid connection out of this is not a practical thing. You will observe if you run the stiffness analysis in ETABS. If you run a stiffness analysis in Idea Statica, you will see that you are not getting a rigid connection out of these two SHS. So you may refer to AISC 358. That will give you some guidelines on how to create a rigid connection between two hollow sections. Okay, so you refer to that. One of the detailing options could be, because SHS to SHS rigid connection is difficult, one of the suggested detailing options could be, this is the elevational view, this is your column. You take a stub like this. So this is the stub of your beam, and then this is the remaining portion of your beam, green, and then you create a extended end plate connection over here. Okay, so you create an extended end plate connection over here by the usual manner in which we do. So this can be one of the solutions where you can try and achieve a rigid connection out of two SHS. So this is not directly connecting SHS together, but you are using a stub and then providing an extended end plate connection. So these were my thoughts on your query. Okay, next question is has been asked by engineer Yash. So he is asking, how to calculate the scale factor for nonlinear time history acceleration to normalize the ground motion, and how to use the, I have no clue. I don't know anything about this. I have not studied nonlinear time history methods. I have no clue. I am unable to answer. Okay. Next question is from engineer Rajat Kumar Kohli. He is from West Bengal, and he is asking, I am working on a substation gantry tower structure, CRB less than, what is this? Less than GIS. and cable support structure. Can you please help me to guide on this design? Now you have to be specific with your query. What is your query over here? If you have any specific query, I request you to please put that in the Google form. Okay. Next question is from engineer Manish Parmar. He is a working professional from Dehradun and he has two queries. So he's saying, for gravity column design, do we need to check the bending moment and shear force which is induced due to magnified EQ force and then design the gravity column? Yes, this is quite clearly given in IS 13920 if you read. Okay. It is clearly given that you have to magnify the effects of EQ force to R time. See, basically they tell you that it should be designed for the displacement, which is R times the design displacement. Okay. So, or let's put it this way: R times the elastic displacement. So, if you want to get the R times of displacement, you need to do the R times of force. So, yes, the what should I say? The language used over there is that it has to be designed for R times the design lateral displacement. So, I'm just bringing a clause from code. Okay, you see this? This is clause number 11 point introduction to clause 11. So it says that for bending moments and induced when subjected to R times the design lateral displacement. So it does not directly say tell you to do the R times design force. Rather, it tells you to do the R times the design displacement. So if you want to do the R times design displacement, the way to do it would be to do the R times of force. Okay. All right. Then next question is, for earthquake analysis in ETABS, we define the EQX, EQY load pattern. So in those EQX, EQY load definition, we input top story as the topmost story, that is terrace. So why don't we input OHT as top story? Because there is so much mass which we assign as water load, so it can play a significant role in EQ analysis. Yeah, you may do that. Nobody is stopping you from doing it. You may do. Sometimes we don't put the top story as OHT because otherwise it will take greater height. Okay, what happens is that your top story will be like this, let's say, and then your structure is below this. So if you define this as your top story, it will take the height from here. If you take a larger height, okay, what will happen that it will take a larger time period. Larger time period would mean that it is going to take lesser EQ forces because that will become a flexible structure if you are taking larger heights. So therefore sometimes we avoid taking the top story as the OHT story because it will lead to under calculation of uh, EQ forces, so to say. Okay, that is the reason that we avoid taking the top story as the OHT story. Clear? Okay. Next question is from. Okay, next question is also from engineer Manish Parmar. He is saying, please explain the side face reinforcement clause for footings. How to calculate and provide side face reinforcement. So code is very clear. If you refer to this clause that you have mentioned, 34.5.2, the code clearly says that you have to provide 360 mm square per meter side face reinforcement and top reinforcement if your foundation depth goes beyond 1 meter. So it's clearly given. Okay, this is that screenshot. Nominal reinforcement for concrete sections of thickness greater than 1 meter shall be 360 mm square per meter length in each direction on each face. So very simple. You on each face, in each direction, that is side faces and top. Bottom anyway, you will be providing your tension reinforcement. So this has to be provided. Your 26.5.1.3 is for beam side face. So that is a different clause. Why are you getting confused? You are saying which clause of IS 456 is for side face reinforcement? It is clearly the 34.5.2. 26.5.1.3 is for beams. There is no scope for confusion. Okay. The next question is from engineer Rohit Dogra. He is from Kangra, Himachal Pradesh, and he is asking how to consider temperature loading in ETABS. You have to be more specific with your query. What exactly is your query regarding temperature loading? If you want the step-by-step method to apply temperature loads, it is better that you watch some YouTube videos or read the documentation in ETABS. So if you have any specific query related, please ask. Okay. Otherwise, I will suggest you to watch the videos on ETABS. Sorry, YouTube videos on ETABS, or go through the documentation. Okay. The next question is from engineer Sanjay Kumar. He is a working professional from India, and he is saying, while designing the base plate, which load combination should be considered? Should I use the maximum force and maximum moment obtained from all load combinations independently? No, you should not do that. Or should I consider the individual load combinations that give the maximum value of each? Yes, you should do this. This is to be done. Okay. This is what you need to do. That you need to consider 3 or 4, let's say, or you need to consider separate combinations. Let's say for one combination you are getting maximum Fy. For that combination, whatever are the corresponding Fx, Fz, Mx, My, Mz you design for that. Then let's say for another load combination you are getting maximum Mz. For that particular load combination, whatever are the corresponding My, Mx, etc., you need to take that. In this way you have to do it. So you do not need to do this. Okay. What is to be done is the second part that you have said. Also, for a shear connection base plate, can the anchor bolts be placed outside the column flange? Technically, you may do that, but then let's say this is your base plate and you're saying that you want to put the bolts over here. Then remember that this, or let's say you wanted to put close but outside, like this maybe. So remember that because now you have put bolts away from the center of, I mean, the bending axis, it may start taking some, if there are any possibility of moment generation, it will start taking moment about this axis. Okay, it will start resisting moments about this axis, although about this axis the moment resistance will remain less because the bolts are very close to the axis, x axis. But about yy it may start resisting moments if there is a possibility of moment generation, because you have taken bolts farther with respect to the yy axis. Okay. Then the next question is from engineer Venkatesh. uh, he is a working professional from Chennai. He is saying, while placing the columns while placing shear walls and columns to suit the architectural plan, how can I position them so that the center of rigidity and center of mass remain aligned within the IS 1893 eccentricity limit without restoring to repetitive trial and error runs in ETABS? Is there any quicker, more analytical way to achieve this? See, it depends on the floor plan, and because your floor plans will never be simple rectangles that we usually see in the solved examples or that we usually get in the books. So your plan will never be a simple rectangle like this, isn't it? Or a simple square plan like this where you know that you can easily place like this and you can achieve the uh, convergence between center of mass and center of rigidity. It will never be so straightforward. So uh, there cannot be any quick fix way. You may have to do repetitive trial and error runs. Maybe with experience, you may be able to reduce those trial runs, but I don't see any quicker way to achieve that. This answer will vary from your plan to plan. Okay. Each floor plan or each structure will have its own limitations. You may want to place walls at some location, but your uh, architect may not be comfortable with those column placements, and so on and so forth. So there cannot be any quick easy answer to this. It will depend on the structure that you are designing. Additionally, are there any quick guidelines for selecting the lateral load resisting system based on story height? You may refer to the table. I think it is 12 point something, table 12.1, I think, of ASCE 7, chapter 12. So that will give you a quick guideline, because they have given you the lateral load resisting systems that are allowed, for which seismic design category they are allowed, for which zone, sorry, up to which height they are allowed, and all those things. So you may refer to that table. I think that will be helpful for you. Okay, good. Next question is from engineer Harish Acharya. He is from Mangalore. He is a working professional. He is asking rather, in safe foundation, what is the linear and non-linear load combination to design the footing? So non-linear, if you have the, I mean, we generally use the non-linear combinations to do the uplift check, whereby using the non-linear combinations, you will be able to see that if in some portions of footing there is an uplift means where the bearing pressure is less than zero as per our nomenclature. Although SAFE considers it positive pressure to be uplift pressure, we, in our discussion purpose, we generally assume negative pressures to be uplift. So what I mean to say is that if there is an uplift in some portion of footing, running an uplift check through nonlinear load combinations will allow you to see that if there is an uplift over here, what is the pressure distribution in the remaining portion, because there will be an increase in the pressure distribution on the remaining portion which is in contact. So you can do that using that non-linear load combinations. How to ignore 40% of the tension in the footing? So that's what I was saying, that if there's an uplift in certain portions of your footing, you need to check that what is the increased pressure on the remaining part which is still in contact, and that needs to be less than the allowable bearing capacity. Okay. These concepts covered in AuxEn's foundation design course? Yes, we have uh, discussed these concepts in detail using manual calculations as well as working on the software. We have done that. Okay. Next question is from engineer Shiva Chandrakant. He's from Vishakhapatnam. He's a working professional, and he's saying, as per my understanding, in order to resist moment in case of pile foundations, pile should be placed in that direction only, creating counter moment. No, piles are not piles do not resist movement by producing counter moments. Pile resist movement by tension compression couple. Okay, so piles connected to pile cap, we don't assume that they will be taking resisting moments on their own, but rather they will resist the moment by generation of tension compression couple. Okay, so if I were to draw a cross sectional view, this is for your pile cap, and suppose you had a moment about this axis, the piles will not develop end moments to resist, it will develop tension compression let's say couple to resist this moment. Okay, is the overturning moment allowed to resist by lateral force? No, that's what I said. By generation of tension compression couples, you will assume that external moments are being resisted, and whatever is the lateral load, that lateral load will be, let's say, resisted by the pile lateral capacity, and that in turn may create some bending in the pile, for which you need to check and design the pile accordingly. Okay. The next question is from engineer Abdul Khaliku. He is from Riyadh, Saudi Arabia, and he is asking, what should I do if my anchors are failing in idea statica? No, you need to see for which action are they failing. Which action are they failing? Uh, Most likely, I am assuming, although you have not provided me any additional info, I am assuming that uh, they are failing for this. What do you say? Breakout strength. Okay, they are failing in breakout. So if they are failing in breakout, there are not much you can do, rather except for providing supplemental reinforcement. Okay, so providing supplemental or secondary reinforcement is a way to avoid concrete breakout, and through that the checks for concrete breakout can be ignored. Okay, the checks for concrete breakout can be ignored through that. When you provide supplemental reinforcement, the process to provide supplemental reinforcement is given in chapter 17 of ACI 318, so 25. So you may refer to chapter 17, how to provide that supplemental reinforcement. And if you have decided to provide supplemental reinforcement, you can switch off the you can switch off the check for breakout strength in idea statica. Switch off the check for breakout strength in idea statica. There is an option to switch that off. Okay, so my answer to your question is that most likely I think it is failing for it is failing against the supplemental, I mean, sorry, it is failing due to concrete breakout. To avoid concrete breakout, the easiest way is to provide some supplemental secondary reinforcement. The process to provide that supplemental reinforcement is given in chapter 17. You go through that process, provide that reinforcement. If you have decided to provide that reinforcement, you can switch off the check for concrete breakout in idea statica. Okay, you may not be able to check the anchors with reinforcement. You need to just switch that check for breakout. Understood? Okay. The next question is from. Okay, so we have taken all the questions from the Google form. Now I'll just take the queries from live audience quickly. Mr. Akash Babar is asking, please explain enforcement details for cantilever walkway of an circular ESR slab. No, what do you mean by explain the details? What is your doubt in that? If you have a walkway, let's say this is your wall of the tank, this is your cantilever walkway. Provide a reinforcement as you uh, do in your cantilevers. What is the explanation that you need is not clear to me. Then next question is from engineer Aditya Raj Mehra. How to check deflection of cantilever beam L by D less than 7? No, how to check means then you will have to model that cantilever in your software, do the checks, do the long term as well as short term check, do the long term and short term checks both. You will have to ensure through your software calculation that your deflections are then within the limits if you are not following the minimum L by D ratios. Uh, Azmi Adil Khan is asking for long-term deflection by cracking the beam in E-tabs. No, so if you, it gives higher deflection as compared with manual calculation, while without cracking it matches with manual calculations. Now, what do you mean by cracking? Are you providing modifiers over there? I mean, what do you mean by cracking the beam in ETABS? I'm not sure. Are you doing the crack analysis in ETABS? So, if you are doing the crack analysis in ETABS, you are not supposed to provide any modifiers. Okay. And what are the manual calculations you are doing? Those things are not clear to me. So, you need to provide me more information before I am able to answer this question. Is there any restriction for spacing of that extra reinforcement? Okay, Mr. Manish is asking related to his earlier question. Uh, the restriction for spacing will be the same that you follow for your other reinforcements. It is better that you provide lesser spacings because that will also help you with crack control. So the spacing criteria, I think you can refer to what you do for other reinforcement spacing criteria. Okay, and my suggestion to you would be to go for as low spacing as possible. Let's say around 100 mm, 150 mm is a good spacing to keep. Okay, Mr. Azmi is adding without modifier. So he's saying, where was his question? For long term deflection by cracking the beam in ETABS, it gives higher deflection as compared with manual calculation. While without cracking, so see, if you are not cracking means if you are just doing the short term elastic, it will obviously match with your manual calculation, because in your manual calculation you are considering the I gross. Okay, and you are doing the calculations, while if you are checking for cracks, you need to calculate the ICR, and then you need to calculate the I effective and all those things. So we have personally seen that the values match. Okay, in either cases they match with the software. So I'm not sure why your values are not matching. What I have observed is that you get good acceptable value matching, and we have done those in exercises for simple beams portals and cross checked with our manual calculations also. So my experience is that they match. uh, so I hope if you are doing the manual checks for crack sections, you are taking the ICR, then accordingly you are calculating the I effective and doing all those calculations. My experience is that the values match. Okay. All right. Then uh, few queries from Mr. Ishan Desai for tall on ground ETP. If the pressure exceeds by double the allowed SBC, what method can be used to solve this? Will providing strap footing along the walls at deeper strata help, as surcharge load will have to be applied on the inner side of footing due to? Yeah, this may help. Providing strap footings along the walls, this may help. And then yes, you need to apply the surcharge load on the inner side of the wall, or providing the pile foundations can also help, provided that your pile foundations are possible over there. You can either provide this by providing strap footings with isolated or strap foundations at the bottom, or by taking pile foundations. Both can be done. Yeah. So whatever is possible on your, I mean, if piling is possible, you could go for piling also. Then for on ground tanks, why do we need to make a separate model to check the global effects of base shear and overturning moments? Why do we need? For sliding, we will have to check it manually, and for overturning, can't the same model be used? I'm not sure with this question. What do you want to say? For on-ground ETPs, do I need to check the effects of sliding and overturning? If I should, then what cases should I be considering for applying loads? No, generally sliding overturning for ground ETPs won't be necessary to be checked, because what will it slide for, isn't it? I mean, how will there be a sliding? Uh, in fact, for underground tanks also, why there will be any sliding or overturning that will take place? Because there is soil from all sides. So I don't see any reason why you need to check for sliding overturning. For calculation of impulsive time period in multi-compartment ETPs, would it be right to check the deflections by applying pressure Q on all the walls facing in one direction? Yes, I would. Yes, it will be. I think it is appropriate to apply the Q pressure on all the walls in one direction simultaneously. See, it will depend on your tank configuration, okay, and it will also depend on your situation, that which some compartments usually will not be filled simultaneously, some will be filled simultaneously. So it will depend on the configuration that you have in your system, okay. As per that, you need to apply your water impulsive pressures or the EQ pressure. So if this was your tank and these are the multiple compartments, this is the plan view. So if all these tanks are going to be filled, then you may apply the pressures on, let's say, this wall, okay, this wall, this wall. In these directions you can apply, and when the earthquake is in the other direction perpendicular, then maybe on this wall, on this wall. So it will depend on your configuration, how your configuration is, okay, like this. Then what are the other questions? Okay, I had mentioned that in my course that a separate model has to be made. Okay, I also don't remember what exactly was being discussed. So maybe I also need to go and see what exactly was the thing that was being discussed over there. Honestly, I don't remember right now. So you may just go back to those sessions and see what exactly was being discussed over there. Okay. All right. Mr. Azmi is saying short-term matches, but for long-term deflection, cracking command in ETAP, the deflection is far higher than the manual calculation. But when I'm not using beam cracking command, see, if you are not using beam cracking command, it is basically you are doing your short-term elastic calculation, isn't it? That will match. Also, you need to see. Okay, I got it. You check that for long term, how you are checking. There is this discussion that is ongoing, especially with respect to ACI codes, that do you need to take the long term deflection in addition to the uh, I mean, the creep shrinkage deflection has to be taken as an additional to your long term deflection uh, due to sustained load effects, or you just need to take the creep shrinkage part separately. So that is one thing that is slightly confusing in the code. The code says that it is an additional thing that has to be added to your sustained load effects, okay. Also, you just see that what sort of reinforcement you have defined, because reinforcements will also impact your long term calculations. So you see those two things, that first of all, how you have defined the long term deflection, whether you are adding the creep shrinkage deflection add on to the sustained load effect deflection, or you are just taking the creep shrinkage part, and also see how you have defined the reinforcement, which reinforcement it is taking. Also check whether you are meshing, you have included, I mean whether you have meshed your beam and slab properly, okay, and whether you have uh, included the beams and slabs in your cracking. So do check all those things, and then we may be able to discuss. Okay. One of the questions was this: engineer Aditya Raj Mehra was asking difference between shear wall and RCC wall. No, RCC structural wall is just a technically more appropriate name for shear walls. Shear wall is not a very appropriate name, if you ask me. Technically, it should be called as RCC structural wall. All right. Okay. So these were all the questions for this week. Now, for any further question, you may put or keep on putting the questions in the Google form. The link for Google form remains the same. Okay, so you can keep putting your queries in this Google form, and once every week when we meet, we will take up your questions as we always do. I hope I have not missed anything. No, I have not missed any question. So this is the link to keep on putting your queries in the Google form. WhatsApp. Uh, ETP is open to sky, walkways at the edge. Could you please give some light? He has put this. This is a horizontal projection. All horizontal projections like walkways and balconies should be designed for 5 times the design. Yeah, so you just take the design vertical AV. AV will be, I think, two-thirds of AH. Accordingly, you consider this. This thing you can do it manually. I don't think you need to do it anything on the software over here. So you just calculate this two-thirds of AH. Okay. And usually it will be less. In your case, if your seismic zone is not very high, it will come out to be less than the self-weight of the system itself. So I don't see any problem over here that you may face. Once you consider the AV in opposition to your self-weight, and for one case you consider it to be acting in the direction of self-weight, accordingly you calculate the bending moments, etc., and design it. Okay. So yes, so this was his question. All right. So if you want to message us on WhatsApp, this is the link to do that. I'll just paste the link. So if you want to connect with us on WhatsApp, this is the link. Just let me paste it. Yeah. So this is that link. So you can click on this and connect with us. So that's all we have for this session. Thank you very much for joining, and have a good weekend. We will see you in the next episode now. Till then, bye bye, and thank you.